So in the last class, we were studying about the ideal series shunt configuration amplifier, so feedback amplifier. So in which we have seen series shunt feedback amplifier configuration. In this series shunt feedback amplifier, so we have just considered the main amplifier, general feedback structure of the amplifier we have just taken into consideration. So in which it is we have taken assumption as that it is going to have a source as well as the load connected to we will be having a source as well as load will be associated with this amplifier. So for that we are going to have a RI input resistance for this amplifier as well as R naught to include the load resistance as well. So the output resistance of the amplifier is given as R naught, and since it is an amplifier, it is going to have a voltage amplifier to be connected. So it is going to have input as well as output signals to be made up of voltage. So Vs across the input side as well as the V naught will be having the output side. So when we need to take the sampling of the output side, so that is voltage signal. So we are going to have a shunt configuration, and when we are going to mix the feedback network to the input side, so we are going to have a series configuration to employ the negative feedback. So Vs minus Vf, that is the source voltage as well as the feedback voltage, will get subtracted to form to give the error voltage, which is millimeter Vi. So in this configuration is called as a series shunt configuration. So this is the ideal case of an series shunt amplifier configuration. And then we can see this is the amplifier circuit. So for which input across the resistance Ri is nothing but Vi, for which the current that is flowing is nothing but II current. So II is the current that is flowing across the amplifier. So this entire setup is nothing but having the input resistance Ri and input voltage Vi to the amplifier input, and II is the current that is flowing across the input stage of the amplifier. And for which we'll be getting a output voltage, which is the amplified version of this input voltage. So that is nothing but A times of Vi will be the output voltage. So V naught is the output voltage that is going to have. So that is equal to A times of Vi. So that is the output voltage. So amplified version of the input voltage that you are going to get, and for which you are going to have output resistance associated for the amplifier, that is denoted as R0. So this entire circuit is called as an amplifier circuit. So we can assume that as a general feedback structure, wherein which you are going to have a signal source and a summer circuit, and then you are going to have an amplifier circuit, and you are going to have an output, that is nothing but a load connected across here, and for which the feedback will be given to the feedback network. So output will be given as input to the feedback network, and the output of the feedback network will be taking the difference, which will be given as input to the summer. So it is going to take the difference from the source signal. So entire thing is nothing but a general feedback structure of an ideal series shunt configuration. So for this series shunt configuration, so we are going to assume that the beta or the feedback network, which is going to connect across the output side parallelly and input side it is connected in series. So this feedback network will be not providing any load to the main amplifier circuit. That meaning is that so amplifier gain is not depend upon this feedback. That means the beta is not going to act as a load. So this on connecting this feedback network, so it is not going to load the main amplifier circuit, so that it is independent of this beta feedback network. So this is nothing but the amplifier circuit, so denoted as A. So A corresponds to the open loop amplifier gain, and then beta corresponds to the gain of the feedback network, and this entire circuit is nothing but the feedback network. So for this feedback network, we are going to take sample the output voltage from the amplifier will be given as input, and for this input of this feedback network, we provide an associate output voltage which will be equal to beta times of V naught. So the output of the feedback voltage is Vf. So this Vf will be equal to beta times of V naught. So this is about the general ideal structure of the amplifier. So series shunt amplifier. In this you can see this Ri corresponds to input resistance of the amplifier, and R naught corresponds to the output resistance of the amplifier. So without feedback network, so this will be the input impedance as well as this is the output impedance of the amplifier respectively. So input side as well as output side. Upon connecting this feedback network, so in the series shunt fashion, so this will now the gain you will be getting as what? So V naught by Vs. So this is the limited gain which is going to have for this feedback network. So if you are not employing any feedback for this network means the gain which you are going to get is nothing but the gain of the open loop amplifier. So open loop open circuit voltage gain. So that means we are not connected load. So the gain which you are going to get is nothing but A times of Vi. This is nothing but open circuit voltage gain. Whereas now, if I am going to employ this feedback network, so the output voltage to input voltage, if you are going to calculate, then the gain which you are going to get is nothing but the feedback gain. So for this, we are going to write the corresponding equivalent circuit. So here, whatever A and beta is there, so this is nothing but amplifier circuit as well as beta circuit is there. So we are going to write the correspondingly equivalent circuit of this series shunt configuration, and then we are going to see what is the feedback gain. So that is the gain which you are going to get with respect to output voltage with respect to input voltage. So another important thing you should remember is this is nothing but an amplifier circuit. So if you consider the loop gain A into beta, so it is dimensionless. So we are going to call it as a dimensionless. Why? Because so output for this amplifier A, so output is nothing but a voltage and input is also voltage, that is V versus V. So beta is for this feedback network. What is the input and output voltage? So input voltage is also in terms of volt and output is also in terms of volt. So it is also going to have volt per volt as a unit feedback circuit, as well as amplifier circuit is also going to have volt per volt. So if you compute the loop gain A into beta, so you will be getting the volt volt gets cancelled, and hence you will be resulting as what? Dimensionless quantity. So from that we can say A is a reciprocal of the beta. So beta will be reciprocal to that of amplifier, or amplifier will be having a reciprocal to that of beta, so that you will be getting the dimensionless quantity. So having this, considering this ideal situation of the circuit, and then we are going to write the corresponding equivalent circuit of this one. So and also we can see on employing this feedback network, so input resistance is going to change. So this input resistance with feedback, it is going to be mentioned as RIF, and the same way output side also the output resistance with feedback is also going to modify on employing this feedback network. So that output resistance with feedback will be denoted as ROF. So this is a ROF is nothing but output resistance with feedback. RIF corresponds to input resistance with feedback. And now we are going to see the fifth important property of the negative feedback, that is on employing negative feedback, how the negative feedback is going to control the input and output impedance. So on employing this feedback network to this amplifier network, so how this feedback network is going to controlling in the sense, control means the input impedance can be increased or can be reduced. At the same time, the output resistance can be increased or can be reduced. That is the meaning of controlling of the input and output impedance respectively. So on employing this feedback network, how it is going to control the input and output impedance, we are going to see in detail. So first two properties have been dealt. So that is reduction of noise, gain de-insensitivity, reduction of non-linear distortion, as well as the bandwidth extension. We have obtained the expression. Now we are going to deal with how to control the input and output impedance. So first, for that we are going to have input resistance with feedback as well as output resistance with feedback. We are going to express the relation between the input resistance with feedback with respect to Ri. At the same time, output resistance with feedback with the R naught. So for that we are going to calculate on employing this negative feedback how the resistance has been changed. So for that we are going to return this equivalent circuit, and then we are going to see what is the input resistance with feedback. So what is the expression for input resistance? Before that we should know what is the gain for this feedback. So since it is a negative feedback, so you are going to have already in the first chapter, already in the feedback chapter starting introduction only, we have calculated what is the gain expression. So that is nothing but A over 1 plus A beta. So it is not going to change. So feedback gain, it is going to be remain same whether what type of configuration you can have, series shunt or shunt series or series or shunt. That means any of the four different type of configuration you can have, the feedback gain is not going to be changed. That is remain same as A over 1 plus A beta, because we have just developed this feedback gain for the negative feedback, general feedback structure for the negative feedback we have employed. So this is a centralized expression of the negative feedback. And now we are going to see based upon what type of configuration, what type of signals you are going to give at the output and input. So for which you are going to get the gain, we are going to find out. So for this series shunt configuration, you are going to have output signal is also voltage, input signal is also voltage. So this corresponding gain with feedback is going to have V naught by Vs. So that is equal to A over 1 plus A into beta. And now we are going to find out what is the how you are going to obtain the relation between input resistance with feedback and output input resistance of the amplifier. So Ri corresponds to the amplifier input resistance, Rif corresponds to the input resistance of the amplifier with feedback. So first we are going to find out what is RIF. So RIF is nothing but the input resistance with feedback. So for this input resistance with feedback, so see the circuit and you can see for which input is nothing but Vs. That is voltage. For R is nothing but what? So R is equal to V by I. So for this RIF will be equal to what? So Vs divided by II. So the current which is flowing through the input side of the amplifier is II, and for the voltage which is going to flow across the input side is Vs. So Vs by II I am going to find. So just substitute Vs by II. So and also we can say that Vs is the source voltage. What is II? So II is the current that is flowing across the input side of the amplifier Ri, for which voltage is Vi is the voltage across this. So what is this voltage Vi? So Vi is the error voltage. So this error voltage has been result because of the mixing of the feedback signal with the input source signal. So feedback signal is obtained from the output of the feedback network, that is mixing across the input side in order to obtain the error voltage Vi. So Vi will be equal to source voltage minus feedback voltage. So that gives the error voltage Vi. So we know that source voltage Vs and minus Vf is going to be equal to Vi. So we are going to substitute the same. Whereas we need voltage Vs. What is Vs? Because here Vs by Ii is there. So Ii is nothing but the current that is flowing over here. So for this Ii, what is the value of Ii? Ii will be equal to I is equal to what? So V by R. So Vi by Ri will be the value. So Ii will be equal to Vi by Ri. And what is Vs? Vs is nothing but a source voltage. So how we are going to represent in terms of Vi? So we have to provide a relation. So Vs will be equal Vs minus Vf will be equal to Vi. So Vs will be equal to Vi plus Vf. So what is Vf? Vf is nothing but output voltage of the feedback. So that will be equal to beta times of V naught. So beta times of V naught. So V naught is nothing but what? So V naught is nothing but the output voltage of the amplifier. So output voltage V naught will be given as what? A times of Vi. So if I substitute over V naught is equal to A times of Vi, so I will be getting Vf will be equal to A into beta times of Vi. So I can just substitute A into beta times of Vi. So minus minus will get so it will be getting a plus Vi plus Vf. So Vi plus Vf is A into beta into Vi, and we will be getting Vi will get cancelled, and we will be getting the input resistance with feedback will be equal to Ri into 1 plus A beta. So this is the input resistance with feedback. So this is the expression, generalized expression, which is going to get. So when you look into this expression, you can say that so input resistance with feedback is going to increase the value of input resistance of the amplifier. That means input resistance of the amplifier is nothing but this is just a open loop amplifier. So for which input resistance is Ri. So when you employ negative feedback, or when you employ this feedback configuration, so your input resistance is going to increase by a factor of 1 plus A beta. So that is the meaning. So that is what when you employ the negative feedback, when you employ the feedback network in the negative feedback, when you employ, so for this circuit, the input resistance is going to increase by a factor of 1 plus A beta. That is how it is going to increase the value of the input resistance by a factor of 1 plus A beta. So what is the function of negative feedback? It is going to control the input and output impedance ಅಂತ ಹೇಳಿದೆ. So this is how it is going to control the input impedance. Input impedance is going to be increased by a factor of 1 plus A into beta. So we know that A into beta will be greater than 1, correct? So A into beta will be greater than 1. So it is going to increase the input impedance by a factor of 1 plus A into beta. So if I'm going to generalize the expression in terms of impedance, so which is going to have a complex frequency variable term, so which is because feedback network along with the amplifier network, it is depends upon the frequency of the input signal. So you can say that I'm going to find out the input impedance. So input impedance I can write in terms of RIF, I can write it as a ZIF of S indicates that is a frequency dependent variable, complex frequency variable. So I am going to have Ri. So Ri is nothing but R Zi of S into 1 plus A of S into beta of S. So this is a generalized expression. So this is about the input impedance is going to increase by a factor of 1 plus a of into b of a and a of s into beta of s. So now in order to find out the output resistance, so r naught and r naught f. So r naught f is nothing but a feedback resistance, output resistance with feedback. So how it is going to relate with the output resistance of the amplifier? So for that we need to find out how to calculate the output resistance. When we look into the previous chapter, so characterizing the parameters of the amplifier. So second module only. So when we are discussing about the characterizing of an amplifier, so we have seen that how to calculate the output resistance. So in that expression, so we have seen the characterizing the amplifier. So we have seen that how to characterize the output, find the output resistance. So output when in order to find out the output resistance, what we are going to do? First, we are going to set the signal voltage to 0. That means we are going to remove the signal source voltage and we are going to make it as 0 in the sense we are going to remove. So we are going to short circuit at the input side so that Vs term is going to be equal to 0. And then we are going to apply a test circuit voltage across the output terminal. So output side only we are going to apply the test circuit voltage. So that is a Vt I am going to apply, for which how much the current is going to be drawn by the output side. So that is nothing but term I. So if I know the value of the amount of drawing current I, and we also know that the value of test circuit, so easily you can able to find out the value of output resistance. So that is the procedure. So I'm going to make it the Vs to 0. So Vs is equal to 0 ಆಯ್ತು ಅಂದ್ರೆ obviously, so the input side of the amplifier I'm just making it to 0, and now left out with a times of Vi, and the feedback network will also be there. So why the feedback network will be there? Because for the feedback network we are going to consider the output voltage. So for this output voltage is nothing but the a test voltage which is going to connect. So test voltage, since test voltage is present, so feedback network is cannot be removed. Only the main amplifier input signal source voltage has been reduced to 0. Whereas feedback voltage is still it is there. So it is going to be connected to the summer. So mixing of the feedback signal will be takes place because the output is the repeated test circuit voltage. It is going to be provided. And now we can see what is the we need to find out what is the current that is flowing over here. So current is a parameter which is flowing from Vt to this R naught. So that is nothing but you can say the value of this node potential is A times of Vi. That is the output voltage of the amplifier. So that is A times of Vi minus of Vt. So A times of Vi or Vt minus A times of Vi. So Vt minus A times of Vi will be the current because the current direction is moving from this side. So Vt minus A times of Vi, that will be equal to the value of current. Okay, so divided by R naught. So I will be equal to what? Vt minus A times of Vi divided by R naught, that gives the value of the I. So we need to find out the value of the R naught now. So R naught of F, that is the feedback output resistance with feedback, will be given as what? So what is the applied voltage? Test voltage Vt. What is the current that is flowing? I is the current. So Vt by I is the current. So now in this, we need to find out what is the amount of current that is drawn. So if I find out the value of the I, then I can easily find out the value of the feedback output resistance with feedback. So I need to find out. So I is nothing but what? I is equal to a time Vt minus A times of Vi divided by R naught. So that is the value of the current I. So what is Vi? So Vi we need to find out. So this Vi is equal to what? So Vi is nothing but what? So it is the difference of the source voltage and the feedback voltage. So source voltage I have set the source voltage to 0. You can see this is the source voltage. So source voltage is set to 0. So Vi will be equal to what? Vs minus Vf. So Vi will be equal to just equal to minus Vf now, because since the source voltage is set to 0, so input voltage will be just equal to the feedback negative, that is minus of Vf you will be getting. So Vf is equal to what? So feedback. So here one feedback circuit will be there, for which Vf we are going to get. Vf will be equal to beta times of V naught. So beta times of V naught. V naught is nothing but this voltage. So this voltage is what now? So I have just removed the open circuit. V naught has been replaced with the Vt. So beta times of Vt. Vf will be equal to beta times of Vt. Now Vi will be equal to minus Vf. Vf will be equal to beta times of V naught. So beta times of V naught is nothing but beta times of Vt. So test circuit voltage. So minus beta times of Vt will be there. So this Vi I am going to substitute as minus beta times of Vt in this expression. So I is equal to Vt minus A into beta times of Vt. So minus minus will get cancelled. Here minus also there. Here is also minus there. So Vt plus A into beta into Vt. So Vt take it as common. So 1 plus A into beta divided by R naught it will be there. So this value current I am going to substitute over in this expression so that I will get the value of the output resistance with feedback. So output resistance with feedback will be equal to Vt divided by I. So Vt is nothing but here and I is nothing but this expression. So Vt gets cancelled and you will be the resulting expression will be having R naught f will be equal to R naught divided by 1 plus A into beta. So this is the output resistance with feedback, and from this expression we can say that so when employing the negative feedback, you're going to reduce the output resistance by a factor of 1 plus A beta. So R naught divided by 1 plus A beta is there. So you can say that the value of output resistance, that is the open loop and output resistance, is going to be reduced by a factor of 1 plus A beta. So this clearly indicates that the feedback, it is going to increase the input impedance at the input side and decrease the output impedance at the output side. So in this way, so the control of the input and output impedance takes place on employing the feedback. So this is the general feedback expression for the series shunt configuration. So series shunt configuration means what? Voltage amplifier, voltage mixing, voltage sampling configuration. So we have found out the impedance changing. So the same way R naught of F, I can write it as what? So R naught of F can be written as in terms of impedance as Z of S. So that is given by Z naught of S divided by 1 plus A of S into beta of S. So this is about the output impedance. So now we'll go to the series feedback. So as I told, so series. So whenever it comes series, so you can say that the input what is the side. So the series it is there. So you can see, and because you can see in this series shunt configuration, you can say in series term is across the input side and shunt is across the output side. So whenever we employ the negative feedback across the input side, if it is series is there means you can blindly you can tell. So input impedance is increased by a factor of 1 plus A beta. So if it is shunt configuration at the output side is there means you are going to have a output impedance will be reduced by a factor of 1 plus A beta. So now the relation of the circuit for the second is nothing but a series configuration. So input side is series, output side is series. So input side series andre no, so voltage as a input. So output side is in series means current. So this corresponding amplifier is called as a current transconductance. Sampling takes place series and mixing takes place in series. So input signal will be voltage and output signal will be current. So since series it is there. So voltage mixing, current sampling. Okay. So voltage mixing, current sampling. So this type of amplifier is called as a transconductance amplifier. So transconductance amplifier we are going to write. So you can see voltage across the input side and current at the output side. So in this you are going to see what is the feedback. So it is the ideal structure of the series series configuration. So in this series configuration, again you are going to see that the input signal source is voltage and the output signal source is nothing but a current. So this is the amplifier circuit. So for this amplifier circuit, what is the input resistance Ri, and what is the since it is a mix series is there at the input side. So voltage series mixing. So here input resistance is Ri. So the voltage is the from the feedback signal will get subtracted from the source signal, and hence you will be getting Vi as the error voltage. So for that we are going to have a current that is flowing across here. So that is Ii. So input side will remain same as that of the series shunt configuration. Okay. So series shunt configuration will hengagitu. So input side will be remain same, and you can say that the feedback network. So here in this feedback network, so output is nothing but a current. So current is getting sampled. So current sample of what should be the gain over here? So you should have a short circuit current gain. So short circuit current gain. So wherein which you will be having A times Vi is the input signal, and then we are going to correspondingly write the amplifier equivalent circuit with the Norton equivalent circuit. So that is A times of Vi is the output voltage. So that is the output voltage when it is connected in parallel with the resistance or not. So you can see the current that is going to flow, that is the current I naught, so that is nothing but a current which is going to have a signal across the output side. So in order to find the, in order to get the output as a current, so we are going to realize this circuit as this one. So once it is done, so the current is there, so we are going to sample the current, means we are going to connect in feedback network in series. So series we are going to connect. So for this input to the feedback network, so current is the input signal, and correspondingly output should be voltage. So for that we are going to have the voltage. So current is the input, so beta times of I naught, so that is the equivalent of corresponding voltage is nothing but Vf. Vf will be equal to beta times of I naught will be having the voltage. So that is going to be mixed across the input side. So this is the general ideal structure of the feedback network, wherein this is the amplifier network and this is the limiter feedback network. So correspondingly the signals and all have been mentioned over here. So now we are not going to derive again for the case of RIF. So RIF, again you can see this is a RIF, right? So we are going to have this is the side where you are going to see the input resistance with feedback. So input resistance with feedback will be equal to what? RIF will be equal to Vs divided by II. So Vs divided by II is nothing but what? So II is nothing but Vi by Ri. So you will be getting Ri and in the numerator, and Vi will be across the denominator. So Vs I can write it as what? So Vf plus Vi, and if I substitute this expression, you will be getting the input resistance with feedback will be equal to Ri multiplied with 1 plus A beta. So you're going to get the same expression. So this is the expression which you're going to get. So feedback gain. So now the feedback gain, you have to write the corresponding feedback gain for this series configuration. So feedback gain, again you are going to have the same gain expression A over 1 plus A beta. Only thing is that now you are going to have the change in the signal. So what is the output current output signal? So it is nothing but a current, and what is the input signal? It is nothing but a voltage. Hence it is called as a transconductance amplifiers. The configuration is series configuration, and the gain we are going to get as I naught by Vs, which will be equal to A over 1 plus A beta. So after finding that input resistance with feedback, you are going to find. So the derivation will be remain same as that of series shunt. So start with RF will be equal to, so Vs by I Vs by Ii. So Ii can be written as Vi by Ii, so that you can say Ii can be written Vs by Ii. So Vs by sorry. So what is RIF? RIF is equal to Vs by Ii. Ii can be written as Vi by Ii. So Ii Vi by Ri. So Ri will be going to the numerator. So Vs will be written as Vs plus Vs can be written as Vi plus Vf, and simplify the expression, you will be getting the input resistance with feedback as the same as that of the series configuration which you have obtained in the previous series shunt configuration input resistance. So input resistance with feedback you have to write same, so you have to derive here. So here they have generally they have given directly, since in the previous we have derived this expression, so no need of deriving again for this one. So I am going just utilizing the expression so as it is. Now if I need to find out the output, so whenever I need to find out the output, so how we are going to make? So input, set the input signal 0 to, set the input signal to 0, so Vs to 0, and connect an output. So here since the output is of current source, I need to connect a current source. So current source I need to test current source I should give. So instead of voltage source, because here the transconductance amplifier output is nothing but a current. So I need, when I am going to set the Vs to 0, when I have done with the Vs to 0, so I need to connect a circuit which is going to have a voltage current source IT, test current source I should connect, and I need to see what is the voltage getting developed across the output terminal, so that I can easily find out what is the value of R0. So the same thing here also we are going to do. So in this series feedback configuration, we have to set the signal voltage source to 0 and break the output circuit and apply the current test circuit. So test current I am going to apply. So that is IT. That is the output side I am going to employ a test current. So IT. So now what is the output resistance with feedback? So output resistance with feedback will be equal to R is equal to V by I. So V divided by IT. So IT is the test current source which I have connected. I need to find out what is the voltage. So what is the voltage? So what is the voltage? Voltage is nothing but across the term. So here it is the limit of voltage, how much the voltage is going to have. So voltage it is having of what? So Vs. So this is the sorry. So what is the voltage across here? It is nothing but a Vi. So what is Vi? So here it is nothing but a Vi is the voltage across the resistance R naught, right? So across the resistance R naught, I am connecting a test circuit IT means. So the voltage across here it will be how much? So it will be equal to Vi. So what is this Vi? So Vi will be equal to what? Vs minus of Vf. Since Vs is set to 0, it will be equal to, so Vi will be equal to minus of Vf. So Vi will be equal to minus of Vf. So I can write, so Vf is equal to what? So that is the feedback voltage. So feedback voltage will be equal to what? So for this feedback, what is Vf? Vf is given as what? Beta times of I naught. So here I naught is nothing but what? It. So it is nothing but a test circuit. So that is the test current which is connected across the output. So that is sampling. So I naught I can write it as a it. So beta times of I naught. So this I naught can be written as it, and Vi is nothing but minus of Vf. So it is equal to minus of beta times of it I can write. So now I can substitute in the value of V, in the value of V I as nothing but sorry, in the place of V I can write it as Vi. So in the place of Vi I can write it as minus beta times of it, and then V will be equal to current. I need to find out what is the current. So current, that is equal to it minus of A times of Vi. So A times of Vi is nothing but the current that is coming across from the feedback network, and it is the test current source. So difference between this into R naught. So V is equal to IR. I need to find out what is V. So V ಕಂಡುಹಿಡಿಯಬೇಕು. So IT we know. So IT minus, so this is the current that is flowing. So IT minus A times of Vs. So that is the button current. So AF into Vs is the button current, because I naught since the output signal is made up of I naught, input is nothing but Vs. So gain, if I want to find out the gain, A will be equal to what? So A will be equal to I naught divided by Vi. So I naught divided by Vi. So Vi I am going to find out here. So we have already found out. So IT minus of A times of Vi. So that gives the difference between the test and the current divided into R naught. So that is the resistance R naught. So it will be equal to Vi. I can substitute as minus of beta times of IT. So I'll be getting IT plus A times of beta into IT. So in this IT I can take it as a common. So if I substitute in the value of V as IT will get cancelled, and it will result in 1 plus A beta times of R naught. So this is the resistance with feedback. So output resistance with feedback is now equal to 1 plus A beta times of R naught. That means whatever the when we look into this expression, if you see what is the value of output resistance, so output resistance of the amplifier is just equal to R naught. Now when you apply the negative feedback, it is going to increase the value of R naught by a factor of 1 plus A beta. That means at the input side also it is equal to 1 plus A beta times of Ri. So output side is also 1 plus A beta times of R naught. So that means when you employ this for this transconductance amplifier, when you employ negative feedback circuit employ ಮಾಡಿದಾಗ, so you will be seeing the input impedance is also going to increase, at the same time output impedance is also going to increase. So this clearly states that whenever you're going to have series term, so in this input side is also series, output side is also series. So you can say blindly, so you can say that the final expression, whatever you are going to get, that is RIF or R naught of F. So you're going to have 1 plus A beta times of Ri in the input side with feedback. So at the output side with feedback, R naught of will be equal to 1 plus A beta times of R naught. So this is the expression you must get at the output. So this is a clue. So in the exam also they may ask to find out what is the input and output impedance for a series configuration or series shunt configuration, like that if they specify. So you have to remember. So whatever if shunt is there, then whatever if the shunt is across the input side, so we'll see in the next term. So if the shunt is across the input side means input impedance divided by 1 plus A beta it is going to have. If it is shunt is there across the output terminal means so you are going to have R naught divided by 1 plus A beta. So this is clearly indicates that controlling of input and output impedance of the output impedance will takes place when you apply the negative feedback. So depending upon the type of the configuration it is, series or parallel. So if it is series means it is going to increase. If it is shunt means it is going to decrease. Corresponding sides it is going to increase or decrease. Hence it is a very important parameter. So on applying negative feedback, it is going to control the input and output impedance. So now coming to the third type, that is the shunt configuration as well as the shunt series configuration. So shunt. So the name indicates what? So shunt. At the input side is shunt, at the output side is also shunt. Shunt indicates what? So input side you must get Ri divided by 1 plus A beta. So at the final expression when you are going to find, so you must get Ri should be Rif will be equal to Ri divided by 1 plus A beta. At the same time, at the output side, R naught of F will be equal to R naught divided by 1 plus A beta. So that means it is going to reduce the input impedance at the input side across the output side also it is going to reduce the output impedance. So this configuration, shunt configuration ಅಲ್ಲಿ input ಮತ್ತು output both it is going to reduce, whereas in series configuration ಅಲ್ಲಿ input ಮತ್ತು output both it is going to increase the input impedance as well as output impedance. So in this shunt configuration, you will be getting both the input and output impedance is going to reduce by a factor of 1 plus A beta. So we will just derive this equation as well. So consider this as the ideal situation. Okay, so this is the ideal situation. Again, consider the amplifier. So before that, I should say what is shunt configuration. So shunt andre ಏನು? So output side, what should be the signal? Shunt again. So when you are going to take the signal in output side, sampling it is going to take across the output side. If it is connected in parallel, so what is that meaning? So that means the output signal is voltage. So shunt across the input side means what? So it is nothing but the current. So mixing is shunt means it is nothing but the current. Sampling in shunt means it is nothing but a voltage. That means current at the input side, voltage at the output side. So corresponding amplifier is what? So that is nothing but a shunt at the input side and the shunt at the output side means, so input is current, output is voltage, so the corresponding amplifier is called as a trans resistance amplifier. So you can see this is a shunt configuration, and this corresponding amplifier corresponds to what? So this is nothing but a trans resistance. So you can see the word trans resistance amplifier. So now I am going to have a trans resistance amplifier for which you are going to have current as the input side and resistance, that is voltage across the output side. So voltage being taken at the shunt, so you can see the feedback network output is nothing but voltage signal. It is going to connect to the feedback network in shunt, and across the input side, so the current mixing is going to take place in parallel. So you're going to have IS connected in parallel with this one. So IS is the current source across input. So here not any current, so you're going to have resistance associated in parallel. So the current source is going to act as the input, and this is the voltage across the input side. That is the error voltage is nothing but Vi. So there is a voltage across this input side of the amplifier, and Ri is the input side of the resistance, and R naught will be the output resistance. And what should be the gain? So gain is nothing but it is going to have a input is nothing but II. So input, because it's a trans resistance amplifier, input is signal is nothing but II. So II multiply with A that gives the voltage. So that is equal to V naught. So V naught will be equal to A times of II. So that is the output voltage. So this is the R naught resistance of output resistance. So we will have, so the corresponding feedback network we are going to see for the shunt configuration. So in order to find out the input and output resistance, how it is going to improve or decrease, so you are going to see the shunt configuration. So feedback gain is given by what? So feedback is nothing but output is voltage, input is current. So feedback gain is nothing but V naught by Is will be equal to A over 1 plus A into beta. So RIF will be equal to Ri divided by 1 plus A beta. So this input resistance with feedback we have seen in the previous case. So series shunt configuration. Firstly, so we have seen the series shunt configuration. So shunt series configuration is the previous slide. So series configuration we have done, we have seen. So series and series shunt. So you're going to have the input resistance having the value of Ri divided by 1 plus A into beta. So R naught of F also you can see, so by equating the expression. So if you understand these two configuration, first two configuration, So shunt as well as series shunt as well as series as well as series shunt configuration. So in this series configuration, um, series as well as series shunt. So shunt at the input side, so voltage amplifier so we have seen the voltage to be at the input side will be having this configuration. So in this we are going to have shunt configuration. So shunt means it is connected in parallel. So we are going to get the input resistance with feedback. If you derive the equation, you are going to get this as the final. So that is Ri divided by 1 plus A beta. And R naught of F also is going to have, since it is going to have shunt, so you have already derived with this equation. So you are also going to get R naught of F is nothing but R naught divided by 1 plus A beta you will be getting. So the input resistance as well as output resistance in shunt configuration. So you can see the on employing the negative feedback, you are going to see the input resistance is reduced by a factor of 1 plus A beta. At the same time, output resistance is also going to be reduced by a 1 plus A beta. So input and output both the resistance is going to be having the reduced factor if you employ a negative feedback for the trans resistance amplifier. The same thing for the shunt series configuration. So shunt in at the input side, series at the output side. So series at the output side means what type of signal you should sample. So sampling is what, whether it is a current or voltage. So current is the sampling. So since series it is there, so at the output side, so you are going to have a current as the output side and shunt at the input side. So you can say that what is the type of signal. So mixing of shunt takes place for which type of signal? So current only. So both are current. So current amplifier it is. So input is also current, output is also current. So this is nothing but a current amplifier. So IS is the current and II is the current that is going to have. So for which the input resistance is Ri. So you're going to have voltage for the corresponding given current input amplifier, that is error amplifier. So IS minus of IF will takes place and then resulting is the II. And the same way, so at the output side, I naught will be the current. So here the gain of this corresponding output amplifier will be equal to, so A times of II. So A times of II will be equal to I naught. So this is nothing but the output side and this is the feedback network. So for this feedback network, input is current and output is also current. So this is a beta times of I naught will be the input. So beta times of I naught will be the output. So I naught will be the input. Beta times of I naught will be the output, that is equal to feedback. So in this way, you can see since the connection at the input side is shunt, so you can see, so the input resistance with feedback is going to have a reduced by a factor of 1 plus A beta. And since the output side it is connected in series, so output resistance is going to increase by a factor of 1 plus A beta. So this is about the four different type of configurations and how it is going to control the input and output impedance. Okay. So any doubt is there? So based upon this theory, so different configuration, so we can able to control the gain. So this is about the four different configuration on which how the feedback network employing the feedback network is going to control the input and output impedance. So with this I'll just conclude today's class. Any doubt is there?